Alice is traveling from 00 to 2020, and Bob is traveling from 60 to 2620, and they may only travel 1 unit up or 1 unit right at a time. They want to find the ways they can travel without intersecting. And here, obviously, A prime and B prime represent the final destinations of Alice and Bob, and A and B represent the starting points. We want to find a way that they can travel without intersecting. So there are a lot of paths obviously that can do this, and for example, you can have something like that, and that's just a random arbitrary one. And we see that this is pretty tough to count directly because Bob's path, if given in Alice's path, it's there's different possibilities for Bob's path for every path that Alice takes, and Alice can take a lot of different paths. So casework is probably not the right approach here, but we see that if you disregard the not intersecting requirement, the total is pretty easy to calculate. It's going to be 40 choose 20 squared, and that's just because both Alice and Bob have to make 40 moves, and 20 of those moves have to be up moves. So and then from those the rest would be right, so just 40 choose 20 squared. But then since it's so hard to count directly, and since the complement of this is pretty well defined, then we can actually easily count this indirectly with complementary counting. And obviously, the complement of this will just be the paths from A to A prime and B to B prime that do intersect, like something like this. So now we see that the intersection points must lie between B and A prime. Since those are the only places the lines can intersect, as the line from B to B prime always goes above 6, the line from A to A prime always goes below 20, so those are the only places that the line can intersect. So our intersection points must be there, and we actually see that this kind of looks interesting, since we can actually draw the line from B to A prime and a line from A to B prime, and that'll still give you all the segments. I'll show you what I'm talking about. So instead of this thing, we're going to do something that's almost the same but slightly different. And for here, we see that we can actually biject the complement of having no intersection to finding the ways to draw these two lines from A to B prime and B to A prime. Now, why is this true? So essentially, we see that since first of all, we see that all the lines in this case, in the second case, must correspond to some cases in this case, because all of the intersections they have are going to be between 6 and 20, and you can't have any other intersections, so those all lie in that case, and you can just really easily find the other, and you can also really easily find this way, derive this way from this way by swapping from getting the intersection points and swapping the blue path for the red path and the red path for the blue path every time you reach an intersection point, and there you'll be able to get the that from this, and we can just do a similar reasoning to get from this to this. So then that's a bijection, and then now we get the so then this That's just obviously going to be like 34 choose 14 times um 46 choose 20, because obviously b to a prime is 34 choose 14, a to b prime is 46 choose 20, so the final answer is going to be 40 choose 20 squared minus 34 choose 14 times 46 choose 20. It's going to be the final answer.